Good morning, students. Let's take the second important topic, that is electric potential and potential difference, from the chapter electricity. Dear students, you have studied electric charge and its properties, and you know that electric charge is the fundamental property of a matter due to which the bodies either attracts or repels each other. So let us start. Let us see. Let us take an example. We take an example of two important examples we will take. Number one, if we take an inclined plane, let this as an inclined plane, and I try to drop a ball from this inclined plane from point A to point B. You see, this ball will drop from point A to point B, because at point A it is the higher height and point B is the lower height. So this is why the ball is dropping from point A to point B. Similarly, if we take an example of two tanks, let's take an example of two tanks. One is tank A. The water is filled in the tank at this level, and second is the tank B. Here the water level is up to this mark. If we join these two tanks with a pipe having a tap T, let's take an example. We will join these two tanks with the pipe having tap. So if we open the tap, you see that the water starts flowing from tank A to tank B. The condition here is that the level of water in tank A is very high and the level of water in tank B is very low. So again, in these two examples, you see the higher level in the height, and here the higher level in the water. The level of the water, the pressure of the water in tank A is more as compared to the pressure in the tank B. Similarly, the height in point A is very high as compared to the point B. So if we see that these ball or the water is moving from the higher levels to the lower levels, in the similar manner, if we see the charge, when current is flowing, the charges are always flowing from the high potential to the low potential. What is this potential? Take an example. We will take an example of a charge. Let us take an example of Q charge. This charge Q, around this Q charge there is an influence. There is a region under which it attracts or repels the other charges. So that influence, that zone, that region under which this charge attracts or repels the other charges, that zone or that region of this electric charge is called an electric field. So this line, this circle indicates, let us consider this circle indicates the electric field of this charge Q. If we place another charge, a small charge, positive charge, Q charge, outside this influence of a Q charge, there is no influence of this Q charge on this small charge. So there is neither attraction nor repulsion between these two charges. So in order to bring this, if we want to bring this Q charge from point, let's take this point as infinity, because it is far away from the influence of the Q charge. Let us take this Q charge from infinity to point A. If we want to bring this Q charge from infinity to point A, we have to do work. Why? Because these are two positive charges, and when we bring them together, there is a strong repulsive force between these two charges. So in order to overcome that repulsive force, we have to do work in order to bring this positive charge from infinity to point A. And thus this work done gets stored at point A as a potential, and we will call that potential as electric potential. So in order to bring this Q charge from point infinity to the point A, we have to do work. When this work is done, in order to overcome the repulsive force, that work done gets stored at point A. So we can say at point A, the work done is stored at point A, and that is called electric potential energy. So we can say, how can we define electric potential? Electric potential, the work done in bringing a unit positive charge, the work done in bringing a unit positive charge from infinity to point A, from infinity to point A. So we can say that electric potential is a work done which you required to bring that unit positive charge from infinity to point A. In this case, you have moved charges. We are moving charges, and to move charges from point A to point B or from infinity to point A, we are doing a work. So we can say electric potential is equal to work done divided by charge. So electric potential is represented by V. So V is equal to W divided by Q. So the electric potential is equal to the ratio between work done and charge. So in order to find out the units of, let's take what are the units of electric potential. So at point A, there is an electric potential, and let us see what is the unit of electric potential. We know that electric potential is equal to W divided by Q. V is equal to W is the work, so the SI unit of work is joule. So I will write here joule divided by Q. The charge, the unit of charge is coulomb. So joule per coulomb. We can represent it like this, joule per coulomb. The joule per coulomb we call as volt. So the SI unit of electric potential is volt. And in order to honor a great scientist, Alexander Volta, the name has been given as volt. So electric potential, the unit of electric potential is volt. So how can we define 1 volt electric potential? We can simply say that an electric potential is 1 volt when 1 coulomb of charge is moving from infinity to point A, and we required 1 joule of work for that. Yeah, when a 1 joule of work is required to bring a unit 1 coulomb positive charge from infinity to point A. So you got an idea what is electric potential. So electric potential at a point is the work done in bringing a unit positive charge from point A, from infinity to point A. Okay, dear students, you know that electric potential. Now we will define what is potential difference. We take in again the same example. We take Q charge, and this is the influence. This is its electric field under which it attracts or repels the other charges. And now the Q charge is at point A. Now if you want to bring this Q charge from point A to point B, from point A to point B, again we have to do work. But you know that at point A there is already a potential. That potential we call as electric potential. If you bring this charge from point A to point B, then another potential is created at point B. But the potential at point A and the potential at point B is different. and there is a difference in these 2 points, the potentials at these 2 points, and that difference we call as electric potential difference. How electric potential difference is created? When you bring this Q charge from point A to point B, then the potential difference is created. So we can say, in order to bring this Q charge from point A to point B, then we have to do work, and that work then gets stored at point B. Then there is a difference in these 2 potentials, and that potential we call as electric potential difference. So how can we define electric potential difference? So we can say electric potential difference is the amount of work done in bringing a unit positive charge from point A to point B within the field, from point A to point B, from point A to point B. So at this point there is electric potential, and at point B now there is electric potential at point B. So in these 2 points there is a different potential, and that difference we call as electric potential difference. And this electric potential difference is very important in order to flow the charge. Now, as you know that the water flows from higher level to lower level. As you know, the ball is dropped from the high height to the lower height, higher height to the lower height. Similarly, at these 2 points there is a potential. The one point is the higher potential and another point is the lower potential. So there is a difference. If we join these 2 potentials, if we apply this potential difference across the ends of a conductor, then the charge starts to flow from high potential to the low potential. It is the similar way that just like a water flows from high level to the low level. So the electric potential difference is the amount of work done in bringing a unit positive charge from point A to point B. So we can say electric potential difference, again represented by V, is equal to W divided by Q, and its units are same. Its units are same, that is, units are joule per coulomb, that is equal to volt. So if we define 1 volt electric potential, so we can say 1 volt potential difference, 1 volt potential difference is the amount of work done in bringing a 1 coulomb of charge from point A to point B and requires 1 joule of work. So we can say when we require 1 joule of work to bring a 1 coulomb of charge from point A to point B, then the potential difference at the point A and point B will be equal to 1 volt. 1 volt. Okay. Let us take an example. Now, what is this potential difference? In order to understand this potential difference, how it is important for flow of charge, take an example again. We take 2 important, this is the one source circle. It consists of positive charges. In case of physics, positive charge and is always considered as high potential, and there is a second sphere which is of negative charges. So this is in positive charge at end of the conductor is always taken as high potential. This is an high potential, and this is low potential. So if we connect these, let A and B is a conductor, and I am applying the potential difference across the conductor A and B. This is A and B is a conductor, and I am applying a potential difference. At point B, there is a low potential, and at A, there is a high potential. Now, what will happen? The charges will start flowing from high potential to low potential. And you know, the flow of charge we call as electric current. So, until and unless we doesn't create a potential difference across the ends of a conductor, current does not flow. So, in order to flow the current, in order to flow the charges, we have to create potential difference across ends of a conductor. So, what are the sources of potential difference? You know, the battery is one of the important source of potential difference. A simple cell is a source of potential difference. Generator is a source of potential difference. And of course, AC sources, they are the sources of potential difference, which applies potential difference across the ends of a conductor, and the charge starts to flow from positive end to the negative end. So now, when we apply a potential difference, we see the charges are flowing. And in physics, we call the flow of charge, we call as electric current. So what is the amount of current, what is the amount of charges flowing from one end to the another end of the conductor in a unit time, in 1 second, the rate of flow of charge, we call that as electric current. Let's take the second important topic, that is called electric current. Before electric current. So electric current, you know now, when we apply potential difference across the ends of a conductor, then the charges are flowing. When charges starts to flow, what is the amount of charge flowing through a conductor in 1 second, in a unit time? That amount of charge flowing through a conductor in a unit time we call as electric current. So electric current is defined as the rate of flow of charge, the rate of flow of charge through a conductor, through a conductor. Rate of flow of charge through a conductor is called an electric current. Let us take an example. Let Q amount of charge is flowing through a conductor in time t seconds. Then current will be equal to, the electric current will be equal to charge flowing divided by time. So we can say current I, current is represented by I is equal to, what is the amount of charge is flowing through the conductor, that is Q divided by T, where Q is the amount of charge flowing through a conductor and T is the time taken to flow that charge. So I is equal to Q divided by T. Let us find out the units of current. So you know the current is the amount of charge flowing through a conductor in a unit time, or simply the rate of flow of charge through a conductor. And the relation for current is I is equal to Q divided by T. Let us find out the units of current through this relation. You know the I is equal to Q divided by T. What are the units of Q? That is charge, that is coulomb. So charge has unit coulomb, divided by, what is the unit of time? That is second. So coulomb per second, we can represent it like this, coulomb per second, or it can be write as coulomb per second. This coulomb per second is also known as ampere. It is also known as ampere. So ampere is the name of SI unit of current, and it is named after Andrew Marie Ampere, in order to honor that French scientist Andrew Marie Ampere. On that name, the SI unit of current is given as ampere, and 1 ampere is basically equal to coulomb per second. So when we say that current is equal to 1 ampere, current is said to be 1 ampere when 1 coulomb of charge is flowing through a conductor in 1 second. So if one coulomb charge flows through a conductor in 1 second, then the current is equal to 1 ampere. So we can say 1 coulomb divided by 1 second is equal to 1 ampere. So a current is said to be 1 ampere when 1 coulomb of charge is flowing through a conductor in 1 second. Okay. So you got an idea about electric potential, potential difference, and obviously the current. So current, now you define, we have defined current that it is a flow of charge through a conductor in a unit time, or the rate of flow of charge. And you know why current is flowing, why charges are flowing through a conductor, how charges are flowing through a conductor, and you know that there is a potential difference responsible for flowing of charge. And if we, until and unless we doesn't apply potential difference applied across the ends of a conductor, until and unless we doesn't apply potential difference, the charges does not flow. So charges always flow from high potential to low potential, and that flow of charge we call as electric current. Now, you know, when electric current flows, it always flows through a closed circuit, a closed path. For example, if we take a bulb, it has wire, and that wire is connected with a switch. Okay, so when we on switch, the bulb is glowing, and when we off switch, the bulb is off. That means when we on, that the current is flowing through the circuit and the bulb is glowing. And if we off switch, that means the current flowing through that circuit will stop. So what is basically that closed path? What is that closed path? And we will learn about these things, how the current is flowing through the circuits, and what is basically electric circuit, and how can we represent these electric circuits. When you in the next season, in next class, when you after applying this NEET exams and other things, when you qualify those exams and you opt for electrical engineering, you have at that time drawing classes where you study how we will represent the electric circuits, these resistors, voltmeter, ammeter, and generators, motors, obviously, and you have to give their diagrams. So let us start a basic thing, that is electric circuit. Electric circuit. Electric circuit. What is electric circuit? A closed path through which current flows. A closed path through which current flows. We can say a closed path through which current is flowing. A closed path through which current is flowing is called electric circuit. For example, we made a simple circuit. For example, this is an electric bulb. This is the wire. We will connect this wire with a potential difference, like battery, 3-cell battery, and there is obviously a key, a switch. So this is a simple electric circuit. So when this switch is on, the current is flowing, the bulb will glow. Bulb will glow. And if we off it, the bulb will not glow. This closed path we call as electric circuit. Obviously, if we see this diagram, you will find there are various components which are joined together and they form a circuit. Like it contains a bulb, is a one component. Second, it contains a battery. This is the second component. It contains key. There's another component, and it contains a connecting wire. That's another component. So when all these components join together, then they form a circuit. So circuit is basically a combination of various components, electrical components, joined together in such a way that they form a closed path, and that closed path through which current is flowing. So let us find out what are the basic components which are using to form an electric circuit. First of all, we will study what is open and closed circuit. So circuits are of two types. Electric circuits are of two types. One is open circuit. Second is closed circuit. Here, open circuit. What does open mean? For example, take this example of this circuit. You see, here the switch is on and current is flowing through the circuit. That bulb is glowing. When switch is in on mode and as current is flowing through the circuit, then the circuit is said to be open. Then the circuit is said to be open. So if we try to understand what is open basically here, any closed circuit where the switch is in on mode and the current is flowing through that circuit, that is called open circuit. So open circuit, two conditions are important. In open circuit, the switch is in on mode and current is flowing. Current is flowing. So let's take this example. This is an open circuit. Here the switch is in on mode and the current is flowing through the circuit. Now the second is closed circuit. Here the switch or key is in off mode. It is in off mode and current is not flowing. Current is not flowing. Current is not flowing in this circuit. So current is not flowing in this circuit. When switch is in off mode and current does not flow through the circuit, that circuit we call as closed circuit. That circuit we call as closed circuit. So obviously this circuit is now, you got an idea that circuit is basically made up of various components, and those components we call as components of circuit, like bulb, connecting wire, battery, key, resistors. All these components together, when joined together in a closed path, they form a circuit, and circuit are of two types, open and closed. Open circuit where the switch is in on mode and the current is flowing through the circuit, and when we off this switch and current does not flow through the circuit, then it becomes an closed circuit. Oh, let us take the different examples, different components of circuit, and how we will represent them individually, those components of circuits. How will we represent resistor? How will we represent voltmeter, ammeter, galvanometer, connecting wire? Okay, all these things. Let us take an example. Let us take another topic, that the components of the circuit. Okay, now the components of circuit. The most important component of a circuit is wire. All other components are connected together by means of a wire. Let us start how. The first component of the circuit is wire. How will we represent the wire? We represent the wire like this. This is a wire, or simply a straight line having two ends. This is wire. So we represent wire like this. But the wire has, sometimes two wires are connected together. That's called a connecting wire. Those points are called a joint. While the two wires are connected, we call that point as joint. How can we represent the one wire is connected with the another wire? How can we show that joint? That is called the connecting wire. Connected wires. Or for example, this is the one wire and this is another wire and they are joined here. So this join we call as joint. So this is the connected wire. And unjoined wire, this is called a joint wire also. Joined wire. This we can show this joint wire. Okay. Now there are sometimes chances that one wire is one wire and the another wire is moving above that another wire, but they are not joined together. How can we show that? Unjoined wires. Those are called unjoined wires. The unjoined wires are representing like this. This is the one wire and second is this wire, and they are not joined, but this second wire, B wire, is moving over the A wire. So this represents unjoined. That means this here represents, this way represents that these two wires are not joined. So this is unjoined. Unjoined wire. So the two wires are not joined together, but the one wire is moving over the another wire. So we can represent this like this. Okay. The third important component. So first component is wire. You show how wire is representing. This is the wire. We represent the wire like this, and the two wires are connected, and where the connection is, that point we call as joint. So these are the two wires and they are joined at this point. These are the connected wires or joint wires. And then unjoined wire. Unjoined wires are like this. One wire is moving over the another wire, but they are not joined together. So this shows the unjoined wire. Now the third important component is the fourth important component, that is called source. Source. You know, in order to provide a potential difference, like we are using iron to ironing my clothes, we use AC source. We connected the lead cord of that iron to the socket, and that socket gives a source of potential difference. Okay. Similarly, if we use a transistor, that transistor has two ends. That transistor has the source of energy, that is a cell, or similarly a battery. So these batteries, cell, generator, these sockets, AC sources, these all are basically sources. Now, how can we represent the simplest form of a source of potential difference, that is cell? So cell is representing. So first off, A, that is cell. Cell, we will represent the cell like this. Cell has two terminals always. This is the wire. One end is connected with the positive terminal and another end is connected with the negative. So this is positive and this is negative. So this is the cell. So when the number of cells are combined together, when the many cells combine together, they form a battery. So we connect the cells together and form battery. The second source is battery. Battery is basically a combination of cells. So I will form 3-celled battery. So in this battery there are 3 cells, 1, 2 and 3. So here is the positive terminal, here is the negative terminal. So join these, negative, positive, negative, positive. So this is battery. Battery is a combination of cells. So this is the second important component. So first important component is wire and the types of joint and unjoint wires. Then the second was a source. First is cell, second is battery, and their representation. Now, the third, that is keys. Keys, in physics, keys are called switch. We use switch for on-off, to break the circuit or to connect to the circuit. Okay, so keys are different ways. One way of representing key is like this. This is off key. If we, the braces, if we represent the dot, this is on key. Okay, the another way is representing like this. This is off. If we join them, these two ends with a line, this is on. The third way of representing the keys is like this. This is off key, and this is on. So these are different ways of representing keys. These are different ways of representing keys. Okay, now the third important component of circuit is a resistor. So how can we represent resistor? Dear students, what is basically resistor? Resistor is a conductor having a fixed resistance which limit the current. So a resistor can be represented. Resistor had two types. One is a fixed resistor. That resistor is represented like this. This is a fixed resistor. And second is a variable resistor. And that variable resistor is representing like this. So in variable resistor, we again named as a rheostat. So rheostat is a device or a electrical device where we increase or decrease the resistance of any conductor. So variable resistor, here are chances that we can increase or decrease the resistance. But in a fixed resistor, there is a fixed resistance in that there. So this resistor, these resistors are basically used to limit the current in the circuit. So this is another component of a circuit. Now this was probably fourth component. The fifth component are the devices. We are measuring devices. We are using various measuring devices in the circuit. One of the important device that we call as ammeter. So ammeter can be representing like this. So this is an ammeter. And ammeter is a device which is used to measure the current in the circuit. So there are smaller scale ammeters also, like milliammeters, and they can be representing like this. So this is milliammeter, that means it shows the reading in milliamperes, and this is the ammeter, and it shows the reading in amperes. So second device is that is called a voltmeter. Voltmeter can be representing like this. So this is a voltmeter, and the smaller scale voltmeter, that is millivolt, that is this. And voltmeter is basically a device which is used to measure the potential difference across the ends of a conductor. Potential difference means voltage. So we represent voltage, we measure the voltage in the circuit through voltmeter. And one important point here which you have to remember is that the ammeter is always connected in series in the circuit. And what is series connection? We will later on discuss it. And you simply remember here that we connect ammeter in the circuit in series, and So far the voltmeter is concerned, it is always connected in circuit in parallels. Okay. So another device that is called a galvanometer. Galvanometer. This galvanometer is representing like this. And this galvanometer is basically a device which is used to detect the current in the circuit. It doesn't measure the current in the circuit. It detects whether the current is flowing through a circuit or not. Thank you very much for the students. This was the topic related to the chapter electricity. Thank you very much.